Let's look at the next part, which is 26.07, 1b. So I'll write that out. Theta exercise 26.07, question 1b. So it says calculate the probability that between 4 and 5 is dispensed. All right, so we've got our Gaussian curve. Here we are. All right, so we've got our mean, and our mean hasn't changed. It's 7. So here's our mean. That's equal to 7 milliliters. And our standard deviation, why can't I see that? Because it's not covered up. Standard deviation is 1.5, so standard deviation is equal to 1.5 milliliters. Now what we're wanting, of course, is we've got these values here, we've got them in milliliters. We're going to have to find a Z value in a moment. Now the question, of course, asks for, and these things we're going to have to turn into Zs, between 4 and 5. Well, let's say 4 milliliters is there, and 5 milliliters, let's say, is there. Well, what we're wanting to do is we're wanting this bit between 4 and 5, which is in there. Now to find 4 and 5, remember, whenever we find a Z-score, it's always the standard deviation from the mean. Here's the mean. So if I find, for example, 5, it's going to give me the probability in this bit here. If I find the probability of 4 as a Z-score, it's going to give me the probability of all of that. So in order to find this band here, I'm going to have to find the probability using 4 milliliters, and it's going to give me the probability of all of this here. Then I'm going to use 5 for my Z, so I can find the probability of this band in here. And then I'm going to take the 5, the result for 5, and subtract it from the result for 4, which will give me this band in the middle there. So find the big one, find the small one, and then subtract the small one from the whole, which is the 4. Here we go. Let's do that now. So we're going to take the Z-score for the 4 milliliters first of all. So I'm actually going to write Z, and I'll put little brackets, 4 milliliters. To remind me what we're finding here is equal to X minus mu over sigma, which of course X in this case is 4, minus mu, which is 7, over 1.5. And that is going to equal, let's find out what the calculator says. It's going to be 4 minus 7 equals divided by 1.5, which is -2. Now the negative doesn't really matter here because the probabilities don't easily give us a negative. You can't have a negative probability. You can have a negative Z, by the way, but it doesn't really mean anything other than that the values we're playing with are below the mean as opposed to above the mean. So we're not concerned with that. We've got a 2. Let's find 2. Here it is. By the way, sometimes the negative Z does play a part. It doesn't in this case, so I'm not going to concern myself with it. There is our 2. And of course, it's exactly 2.0. Here's the 0, 0, 0. And 2 is 0.4772. So the probability we're going to deal with, the probability is 0.47, whoops, can't see that, 0.4772. And that's the first one. All right, let's do the second one. All right, so I'm going to create a little bit of a gap here. So let's find Z value based on 5 milliliters. And this is, when I found the 5, I'm going to subtract that from the value I got for 4. So here's my 5 milliliters. Oh, sorry. That's a 5 milliliters. Here it is. And that is going to be X, of course, minus mu over sigma. Our X value is going to be 5 minus the mean, which is 7, over sigma, which is 1.5. So now we've got, let's have a look. And we've seen this actually before, I think, because it's 2. So 5 minus 7, there's our 2 again. And I'm just going to divide that by 1.5. And, oops, 1.5. Here we are. And it's 1.3. Again, it's a -1, but we don't have to concern ourselves with that. So we've got 1.3 recurring. So we're just going to find 1.3 recurring. So we've actually done that before. I think you recall. Here's 1.3, 3, and then we had that other bit of the 3 on the end here. So it's going to be 0.408. 2 plus 5 is 7, so 0.4087. So the probability is 0.4087. And I implore you to put a leading zero. I don't, simply because I normally wouldn't. Okay, so what we're really finding, so what are we finding here? We want to subtract these two. So what's that value going to be? So I'm actually going to state this a bit differently now. I'm going to state the answer. The answer is going to be the probability that Z, and I'll put Z here in the middle, is going to be less than 0.4772, 0.4772, and greater than 0.4087, 0.4087. In other words, it's going to be this band here is equal to, and I'm going to take that subtract one from the other, I'm going to take 0.4772 minus 0.4087, and I'm going to subtract those two. Let's see where I land. So I've got, so you can't see it and I can't see what I'm doing here. So okay, I'll go. So 0.4772 minus 0.4087. There we go. And we get 0.0685 equals 0.0685. And that's the probability. Now, at this point, again, you want to make a statement, an actual written statement, and it should go something along the lines of, and by the way, I would definitely include this here because it's between 2 points, and I would state something along the lines of the probability that the soap dispenser produces between 4 and 5 milliliters is going to be 0.0685, in other words, 6.85%. And that is how I would find the solution.